Problem is bit tough, but we'll try how much we can proceed with this. It's not really tough, but for explanation, it has a more to go compared to usual problems. So given a graph of n nodes with red and green edges, the edges available means the edges available in the graph have either a red or a green color, and this is a directed graph. Find the minimum distance to every node from node 0 by choosing alternating red and green. That means you will be starting from 0. You have to choose either green. Once you choose red, then next choice should be green. If you choose green, the next choice should be red. That must be the way you will be selecting your path. That's the only condition you have. And with that, you have to find the minimum distance to every node from node 0. So you have the total number of nodes as 10. You have red edges, you have green edges. We have to create the graph. This graph is very different compared to usual graphs we deal with. We will create. Now we need a very specific. Now we need some kind of with as GPS. I will keep it here. What happened is we created a graph named grid, which has adjacent nodes. For each index, we will create a list of adjacent nodes, and for green nodes, we will create an adjacency list. For red nodes, we will create another adjacency list. So that way we can easily differentiate between red and green. Now we have to actually create the graph. For I less than n distance greater 0 under push back. What is that you have to push? It's just height n. Now we need green. So we have red edges, we have green edges. Both adjacency lists are created. So it has to go at 1. Yeah. Both adjacency lists are created. Now we will be creating a queue. Queue of 10. Queue will be starting. Okay. That's how it is. Now we will be q dot push 0 0 means be exploring q starting from 0, red path. 1 means we'll be exploring starting from 0 over green. Now we will BFS. As long as q is not empty, q dot not equal to height of 0 equal to So now we have our current node and current color. So you proceed to the next. It has to be a different color. Right. That will be 1 minus the current color and the V node. Okay, now we have next node. Then we will reach before this. We have to initialize something to identify the length vector. To identify the current status of with this resultant answer. We'll be exploring either with 0 or with green, starting either with 0 or green, with green. So the resultant answer, you will have two set of resultant answers. For green, there will be one, for red, there will be one. So you will initialize that answer 2a because the maximum possible won't never hit 2a. So that is condition we will check inside that first. If length of current color next length of current color what will be the condition? So you are checking what are the possibilities you have for the next one. If you are next, if it is 2a, that means you will be switching into a different color. With that color, your target has length equal to 2n. Then update the target with the current one. Then we need some initialization over here. So 0, 0, comma equal to 0. Length 1, comma equal to 0. Yes, this shall work. So your target will be updated. With current plus 1 and your target will be enqueued. What is the target? It will be next. Now you will have a set of distances depicted in the form of n. Now you need a final answer of length n. That is the least distance 0 to that index. Certain result of I will be min of 0, the 1, I. If it is started with green color, what is the distance? If it is started with red color, what is the distance? And result of I equal to a initialization value. Just make it as result minus 1. That's not what we 2n is our initialization condition for the sake of BFS. We could even keep a minus 1 as is. We could keep minus 1 as is. If we keep minus 1, we will not be able to do this operation. It's picking least 2 will be a bit hard, so let's keep it as. Now you have answer. That's the solution. Test is more decline on the score. It is hence the seeing something wrong. Okay. Dot pop is not there. It is not coming out of the loop. 0 minus 1 minus 1. That is a wrong answer. That is the answer. So how to solve further. Line coding is always a tough process, so we need standard methodology to approach these kind of problems. Where is the target? It's so true. Third color. So now what? This time. Yeah, this is presumably correct. Let's check with the answer. So we have blue edges away, no green edges. 0 to 1, we can go with a blue edge. Then after we can 1 to 2, we can run because we don't have any. From 0 to 2 also we have many edges. So the first answer is correct. For the second one, 0 to 1, we can go with edge. For 1 to 2, there is no trap. This is a directed graph. There is 2 to 1, there is edge plus 1 to 2. So for say similar answer only, this is a correct solution. Thanks for listening.